lesson 11, we are going to talk about inscribed angles, which are special kinds of angles in a circle. So we have a circle and then we draw some angles. And then we're also going to do some more where we have those abstract fractions, so fractions with variables, but we're going to actually be adding them together, not just simplifying and combining the like terms, but adding the whole thing together. So first we need to understand what angles inside of circles are. There are two that we care about. Central angles have a vertex at the center of the circle. And inscribed angles have their vertex on the circle. So the only difference in central and inscribed is where the point is, where the vertex is. Either the center of the circle or on the circle. For both kinds, we say that we have what are called intercepted arcs, and that is the part of the circle that the angle catches. Is everybody okay if I go far enough down that we see the intercepted arc or the inscribed arc? We all have the central angle, okay? So then the inscribed one looks more like this. And then we're going to put an important relationship about those into our formula list of formulas that you need to know. So when we have a central angle, we could pull out a protractor, except we never really actually do that, and we could measure how big is this angle. We also talk about how many degrees it is around the circle, what's the arc length, and so the degrees for this piece of the circle, if it is a central angle, the degrees for the arc are the same as the degrees for the angle. But if it is an inscribed angle, it's going to be a little bit different here. So let me just for a moment draw an inscribed angle on this top picture and then I'll erase it. So don't actually copy this. So this X and this Y have the same degrees. Now I'm going to draw an inscribed angle that has the same arc. Just as you look at that picture, does that red angle look the same as the one that has the center at the vertex, or does it look fatter or skinnier? It looks smaller, right? And it is. The inscribed angle is always smaller than the central angle. So that inscribed angle has to have a smaller measure than Y. And specifically, what it has, that line that I just drew there. Specifically, if it is an inscribed angle, it is half of that arc. Or sometimes we want to say that the arc is 2 times the angle. Just multiply both sides by 2. We're close to everybody having that down. Next thing we're going to do is we're going to try practicing using what we just learned. See if we can find how big angles are or how big the arcs are in some pictures. So here's our first example. So I've got a picture, got a circle, and I've got an angle in there, and I want to know, is that angle an inscribed angle or a central angle, everybody? Good, it is an inscribed angle, so we know we are looking at an IA inscribed angle in there. So I know that that 40 has to be, what was the formula? The angle is, well, sometimes I'm going to scramble the y's around. Don't memorize it with x and y. Memorize it that when it's central, the angle and the arc are the same. Memorize when it's inscribed, the angle is half of the arc, or the arc is twice the angle. Because I could change it on my next one and put an x over here and a y over there. If you've memorized it this way, you've got it backwards. So always memorize the ideas, not the specific labels. So with this one, without saying y, what's the relationship? 40, the angle, is half of the arc, right? So we can say 40 is half of the arc, or if we multiply everything by 2, everybody, how many degrees? And our reason was inscribed angles right there. So now we know this is 80. But I also need x. Does anybody know a relationship that I can use for those x's? I tried to highlight them in different colors. The blue part is 4x plus 20. The pink, purple, whatever you want to call that, is 5x plus 80. And the yellow one we now know is 80. Do we have any relationship that we can use to solve that? Hendricks? Solve a circle. What's a circle add up to again? So we are going to write down, you guys go ahead and solve this one. We're going to write down 4x plus 20 plus 5x plus 80 plus another 80 is 360. Race me, see if you guys can get it faster than I can. And that's going to be circle sum for our reason. Some of you are super fast, and I've already gotten all the way through there. Shout out, what is x? 20. Great job, x is 20. I combined my like terms for a 9x. I combined my numbers on the left and have 180. Subtract that both sides, leaving me 9x is 180. Divide both sides by 9, and x is 20. You guys are awesome. Proud of you. All right. Other topic for today is actually add these things together. None of those are like terms. So far all we've done is write them all positive and see if we have any like terms, and only put together the ones that are like terms. Now we want to figure out, even if they don't really match up, how can we combine them? So remind me, if I just had numbers, if I wanted to add 2/3 plus 4/5, what do I have to do when I'm adding fractions that have numbers running around in them? Bella? Find a common denominator. So that's what I need to do. So for these, my denominator needs to have a 3 and a b. So I've got that in my first one. It needs to have a b, okay, I've already said that, and it needs to have a z cubed. And I look at the other one, it needs a b, I've already got that, but it needs z to the 4th. I don't have that much yet. I have 3 of them, but I need 4. So my common denominator needs to be 3b z to the 4th. So I need to look at each piece here and say what is missing. If I need 3bz to the fourth, I have the 3 and the b here, and I need a z to the fourth. So I'm going to multiply numerator and denominator by z to the fourth. I can't get rid of my denominators. It's not an equation. I can't multiply both sides by the common denominator. I have to actually get it and add it together. For the next part, what am I missing, Alexander?
You're missing 3z.
I'm missing, good, 3 and a z. So I need to multiply numerator and denominator by 3 and z. Connor, what about the last part? What is it missing?
Missing 3.
It's just missing the 3. So I show multiplying numerator and denominator of each. Put them together. My common denominator is 3bz to the fourth. And in the numerator, I have mz to the fourth. A little hard to read my writing there. Plus 3akz minus 3y. What do you think? Does that work? Question, Jonas.
So if you had, say, two, like, denominators and numerators,
If two of the denominators were the same, and what?
well, even if they weren't the same, but if you made them the same, and if the numerators were just the same, if you had them to...
If you have like terms, and yes, you do look at the numerator, is anything a like term now? And if so, you combine it. Anytime you have like terms, you will put those together. Great question. All right, let's try one more example here. So everybody look at those and write down on your paper, what do you think we need for the common denominator? Just write that much down. What do you think the common denominator would be for all of those? Anu, what do you think it should be? Okay, A and B. AB squared, do you think is what we need for the denominator? Well, we're going to see. If we go with the AB squared, okay, we've got the B, and then some extra. We've got the A, and if we just go with B squared, we don't have everything we need here, so you're exactly right to change that to AB cubed, and then we have everything we need. So now, Alex, what is my first one missing?
A and the 2.
So it's missing A and B squared, so I write it down twice. Can't multiply just the numerator or just the denominator. We have to multiply them both to keep it equivalent. Now the second one is a little bit tricky. What are we missing in that second one? Akshita? We're missing the whole thing. So we need the AB cubed. So we put that with numerator and denominator. What about the last one? And what are we missing on our last one, JC? We have everything, so we don't need to change it. So then we just write it all together, AB cubed, and the numerator is AB squared Z minus AB cubed K plus 2MN, and none of those terms are exactly alike, so we can't combine any of those. So any questions for that? Right.
So let's say it was like 2ab cubed z minus ab cubed sorry. I'm trying to say this, but it's really hard to say.
Yeah, with all these letters, I get my tongue tied all the time.
Let's say it's 2ab minus just ab cubed, right? So I'm trying to make them the exact same but have a number in front of them. And so then how would you subtract that? Would you not?
With these, I can't. The letters and exponents have to match. If this were 2ab cubed minus ab cubed, you would put those together as one ab cubed.
Okay, now that's my question.
Good. I love all your questions. You guys are doing a great job with that.